Okay, I would like to draw a histogram from a box plot. So, suppose you're given some sort of box plot, and we'll make it look very non-symmetric here. Go about like that, maybe. So here's a box plot. And what I know is this is the median. There's the third quartile. There's the first quartile. Here's the min, and here's the max. So now what I want to do is sort of turn that on its side. I'm going to come down here a little bit. We'll say it looks like this, where that's the min, that's the max. And I won't be extremely accurate, but as we look at this, we see that, you know, maybe if the Q1 was there, the median was up here quite a ways. And then pretty close to it was the third quartile. So we'll say that is turning this thing up here on its side. And now what we know is that each of these, we have 25% of the data there, 25% there, 25% there, and 25% there, which means that as a histogram, relative frequency diagram kind of thing, each of these different, four different segments needs to have a rectangle all with the same area. And so, for instance, you know, what I know is this one is going to be the tallest, because to get the same area with a shorter base, I need something very tall. And this is going to be the shortest because, again, if I want 25% of the data, so the same area, it's going to have to be short. And then this one is not as short. And this one seems like it should be the second tallest. So I can be much more exact, but just to get the idea here, you just want to realize that, okay, if this is A1, A2, A3, A4, that those areas we need A1 to equal A2 to equal A3 to equal A4. And so now suppose I had some numbers. So again, you know, here's some box plot. We'll do it something more like this, and we'll give it numbers like maybe, you know, this is 5. We have maybe 9 here, 12 there. Then what that looks like, if that was 3 there, that's maybe 3 times that or so. So we'll say this is 21, and we'll say this is maybe 34 or something like that. 35, we'll call it 35. Why not? Okay. So suppose we have those numbers, then if I were to lay this down, we have 5, 9, 12, 21, and 35. Okay, so this is a distance of 4, this is a distance of 3, this is a distance of 9, and this is a distance of 14. It doesn't really matter what I make the area. I could make the area of each one, you know, maybe, suppose I went with an area of, I didn't choose great numbers here to make life easy. So maybe I'll just go with an area of 12. I'll make each one an area of 12. Well, if I do that, then we'll say there's 1, there's 2, there's 3. I need this to be 3 high to get an area of 12. And again, area 12 is just a number, but I'm going to make them all an area of 12. So this is at 3. This one is at 4 to make an area of 12. This is 9. So to get an area of 12th, I need to multiply by 12 ninths. And so 12 ninths is what, 1 1/3. So that's maybe about right there. So that height is going to be 4/3, and I'll get an area of 12. And then here, 14, well, 12 over 14 is 5/6. So, you know, down here I'd be at like 5/6. So this would be a little shorter like that, and that has an area of 12. So again, this has a height of 3 here, height of 4, a height of 4/3, and a height of 5/6. And I get that same area for each one, so that would be a histogram that I could, a pretty accurate one if I did it nicely to scale on a piece of graph paper or use technology or something. But that would be a very accurate histogram as far as the relative sizes of each piece. Okay, so that is taking a box plot and drawing a histogram from it.